I just want to thank you for joining us today. We look forward to a great discussion on the topic consumer or professional, which 3D scanner is right for you. We got a really great session for you today. I'm excited to introduce my colleagues and our presenters for today, Paul and Art. Drawing on their hands-on experience from using a variety of 3D scanners, from consumer grade 3D scanners to professional grade 3D scanners, and working with a lot of our customers, they'll be sharing their insights and their best practices on how to select the right 3D scanner that's right for you. So with that, I'll hand it over to Paul.
Thanks, Pauline. So, thanks everybody for joining us today. Just to give you a little bit of background, my name's Paul. I'm with Go Measure 3D as well as Art. And between the two of us, we have roughly 30 years of 3D scanning experience. So, I started back in 2005 and have been using a variety of 3D scanning equipment over the years. As you can kind of see on this slide, that's a image of a much younger version of me using a completely different 3D scanning system. And over the period of time, we've learned quite a bit about technology, what it was, what it is now. And yeah, we're really looking forward to kind of talking with you about, what's on the market and what may be applicable for your application.
I'm Art. I'm coming from a university background, from a historical preservation perspective in the beginning, but it's been about 10 years I've been using 3D scanners, now working with Go Measure 3D. But I've used the spectrum of iPad scanners to consumer grade, low-end scanners to LiDAR, high-end and structured light scanners. And currently I'm playing around with photogrammetry and SLAM-based LiDAR mounted to drones and things like that.
Really, what we want to talk about today is kind of the key points of what you want to look at for uh, the 3D scanner that you're trying to purchase. So when we're looking at the current, market, there's a lot of consumer 3D scanners out there that are getting really good. There's also very good professional grade 3D scanners. And, what me and Art have kind of come up with here is there's three main categories that you kind of want to look at when it comes to 3D scanners. The first one's going to be accuracy, then your scan data quality, and then your overall real world experience.
Exactly. So you may be coming here with like a specific use. You may be looking just to do reality capture, maybe historical preservation, education, VR, 3D printing, things like that. You may be coming here for inspection, reverse engineering. May sound like high-end applications, but those different applications, which we'll reach at the end, they can all be used through the spectrum of like consumer to professional grade scanners. So as Paul is saying, kind of in our experience, and we want to update this every year, the 3 points that affect maybe your decision would be like accuracy, how important that is, the scan data quality, which is really like the look of it and how clean it is, and overall like the smoothness of your experience. Is it going to take you a long time and a lot of clicks to get a nice model out, or is it just going to be very, very easy and sleek? So I like to make a comparison to 2D cameras. I'm a photographer before this, and it's a really good analogy to think about the state of the 3D scanning industry today is a lot like this is a camera from my father's generation. This is a film camera. You used to have to know how to use uh, ISO, aperture, shutter speed, things like that. And then you have to take this film out and develop it. And then you could print a picture and finally get that 2D image out. Well, the 3D scanning is a little bit closer to that, I'd say, right now. Even though it's very high tech, it still takes skill to capture a nice 3D model and to then render it out into like a file type, a format that's usable from that raw image, whether it's point cloud data, laser data, or structured light frames, to a nice unified mesh with color if you need that, or just a watertight mesh for 3D printing or reverse engineering. That takes more involvement. It's not a one-click solution. So we've kind of gone to cell phones. These cameras here are very, very good at taking photos, and there's a lot of software built in. They smooth out our faces and skin and correct for white balance and perspective and all kinds of things. Now there's AI tools, but you still have cameras like this. So a professional right now we have the World Cup going on, and you see people, professional photographers, using these cameras on the sidelines because these are specialized tools for a very specific task. Getting that fast sensor readout, getting 30 frames per second for images these days. And even though these photographers have their Instagram channels and they have incredible photos coming out of their cell phones, um, they're still using a lot of tools. So there's a lot of tools in your tool belt, and that's what we kind of want to talk about today and complicate the picture. Like you don't need the best 3D scanner. Maybe it's the right tool for the right job, and you may have multiple tools in your pocket. Um,
Right.
and so all that to say, my main point kind of today is that you'd be surprised that a skilled user can get really great scan data out of all kinds of 3D scanners, whether it's a $200 one off the internet or a 40, 50, 100K solution.
Right. No, exactly. Just like you mentioned, you can take an iPhone and do a lot with it, but there's certain applications where you need that DSLR. And, one of the more mechanically type analogies I like to use is toolboxes, right? So, if this may resonate with some people where you have a project you're working on, right, where you need a really specialized tool, kind of like a 3D scanner, but you may only use it once or twice a year. So you go get that tool from a company like Harbor Freight, right? Or in Canada, it'd be like Canadian Tire. Whereas if you're doing that professionally and you're using it every day, you may not buy that Harbor Freight tool. You may buy the more professional version. Same thing like we kind of see here with welders, right? Uh, if you're just doing a little bit of hobbyist welding, you may just want to get an entry level system. Whereas if this is something you're using day in and day out, what you pay for quite often is what you get. And we really want to break that down because if we kind of look at just the general 3D landscape, or 3D scanner landscape rather, there are a lot of different companies, a lot of different scanners out there on the market. This is just kind of an example of a few of the scanners that you can see from your consumer grade 3D scanners all the way up to your professional grade, right? And there's many more brands than this. So, one of the real purposes behind this webinar, that me and Art talked about, or one of the reasons we talked about doing this is just to kind of not necessarily tell you exactly what to buy, but to kind of break down this market to give you a few key points of what's really going to matter.
Yeah, just to before you go on to the next
Yep,
slide,
go
Paul,
for it.
I'll say if you want to come back to the other one,
Mhm.
there's a lot of these that we have used. And even to the earlier point he was making, I recently called Paul and he helped me make a decision, and I ended up getting a Harbor Freight like a flux core welder as my first welder, and it's $150, and actually has been doing the job really well. We talked a little bit about splatter, this and that, and it was the right thing for me to work on my garden beds and get the iron edges and things like that
Yep.
finished. So as far as
So,
the 3D scanning landscape, I just want to mention some of these by name. On the what I started off at the university level, I was using 3D Maker Pros and structure sensors. The structure sensors are mainly the device that um, the scanner attached to iPads that there's like hundreds of apps for. So there's an SDK and people develop their own kind of 3D scanning apps for medical uses and things like that. Revapoint, Creality, Shining, and even Artec have now kind of entered this consumer grade market. Artec's photogrammetry software with just cell phone cameras can create pretty nice models. On the opposite end of that, we have Artec as with their structured light systems, their laser systems. Zeiss is very, very high end, excellent. We have Faro with their systems as well as their arms. Creaform. LMI technologies, which we've been involved with, and Skinology. And then kind of in between every one of these, sometimes it slides into the middle, whether it's from the consumer end or from the professional end. You've got 3D Maker Pro making scanners like the Eagle, which are going to be your SLAM-based LiDAR, which are great for surveying, and you have Peel 3D there as well. Creality has been really impressive this year. And you have Matterport as well. And of course, Shining 3D also coming up from that consumer end of things. Just wanted to, is there anything else maybe that comes to mind, Paul, in terms of the landscape?
Yeah, no, I think you nailed kind of the big players right now.
Yeah, yeah. So we're not at this point of this webinar isn't necessarily to try to companies against each other. It's to have a more general discussion. So we're not gonna like throw out any names and throw anybody under the bus. But we will be making other videos later to do like more demos and comparisons.
So, Paul, you showed the slide, and we're seeing the three scanner landscape there. And you can see there's so many different options out there from different three scanner manufacturers. So, choosing the right three scanner for yourself seems like a very overwhelming sort of project. So, to narrow down the options, how do you know whether a consumer or a professional grade three scanner is a better fit? In that instance, like what factors should a person consider to help them make the right choice when they're trying to figure out which three scanner is right for them?
Yeah, no, that's a really good question. So there's a few kind of objective factors that we want to go through here. And the first one you really need to look at is the type of technologies that are on the market. So you can see here we've got uh, various forms of sensors and various forms of tracking. So with your sensors, you've got your structured light, laser, time of flight, LiDAR, SLAM, photogrammetry. Now, these are all terms that you're going to hear when it comes to types of 3D scanners, as well as their tracking, which would be marker-based tracking, texture and geometry tracking, or encoder, which would be your older style of like 3D scanner, 3D scanners attached to arms. So really, with these technologies, sensor-wise, the two big ones to look at are structured light and laser for most handheld 3D scanner applications. If you're scanning large areas, it would be LiDAR or SLAM. But that structured light or laser are the key points we'll focus on today. And then additionally, with the tracking, we want to really compare your marker-based tracking versus your texture-based tracking.
Yeah, I kind of want to focus a little bit more on tracking there and kind of describe the technologies. A lot of times when people buy a scanner from us, we'll talk about developing the skill of capturing that image. And so, besides making the movements with the camera, you've got to be able to point the camera at every surface at the right angle and the right distance to help the scanner see and capture the surfaces. But how does it know the movement, right? Some systems have like an external vision system. Some of them will capture a target cloud before starting scanning. Those are using those reflective markers. And then some will focus on just the scene itself, the unique geometry and color information available, and lock onto it and then build out the model as you move across it. Um, so tracking is that movement, understanding where the scanner is in 3D space in relation to the object. And then registration is the real time of aligning of that newly collected data um, to the previously recorded data. But then also there's another registration algorithm that happens in the software later with a more powerful processor just to ensure accuracy and actually kind of close the loop and ensure a tight fitting of all the surfaces that gives us the best reconstruction of that real world object. Um, so how do we want to talk about this? I guess in some sense, like the consumer versus professional, um, what you're going to get on the consumer end of things is not as good of a performance. So those systems generally don't lock on and hold on to the object as well. And so it requires a little bit more skill. It requires a little bit more time and care. Um, and generally, on the consumer end of things, if there is a solution that does use markers, that tracking and registration will give you a better quality scan. Um, of course, there's that downside of having to place those dots on everything that you scan.
Right.
They collect generally a little bit less data, those marker-based systems. And so the file sizes are a little bit lighter and it's easier to use that way. On the professional end, everything kind of gets quicker and higher quality. So there are systems out there that are just great without markers. They're able to have a sharp view and a large depth of field because of the optics of those more high-end cameras. And therefore, they're able to kind of like just scan a large object or anything without any markers, just because that vision is so clear and the processing power is available to register everything in real time. Um, and of course, there's also the kind of the hardware side of things.
Yeah. Yeah, and just to add a little bit to what you're saying, Art, for the on the consumer side, like you mentioned with the markers, uh, those scanners are really easy to use when you're trying to go to the geometry and texture. uh, there's still a gap between the consumer and the professional side, right? And then, some people may ask, well, why are there still professional systems that use tracking dots and markers, right? And those systems are primarily doing that from an accuracy standpoint, right? If you're trying to get your metrology grade, inspection level scan data, then most of the time we're going to need some sort of a tracking marker to do that. But as you mentioned, kind of getting into the hardware side of things, um, really with 3D scanning technology, at least the way that I see it, looking back on the years, the technology really hasn't changed as far as its baseline principles. So, if you think about how a 3D scanner works, or just to kind of give a primer for anybody that doesn't know, generally there's going to be some sort of a projection system, right? So that's either that structured light or laser projection that we're talking about. And then there's going to be either one camera or multiple cameras that are looking at that projected image and then translating that into 3D scan data. So as you can kind of uh, correlate with this, when you're looking at consumer grade systems versus professional, generally your professional systems are going to have higher resolution, higher quality image sensors, optics, and if there's processing, onboard processing. Whereas your consumer grade, from a price point standpoint, generally you're going to have, lower grade sensors and optics. But what does that really mean from a practical standpoint? So practically, with a consumer grade system with the sensors, right? So if we have less resolution on the sensors, what that usually means is for scanning an object, right? I think Art, you'll have some good examples of this here in just a few moments. But with a given size part, or let's say you're scanning something the size of a microwave, right? With a professional scanner of a volume that could easily scan around that microwave in just a couple of seconds, you would have to use a smaller field of view to achieve that same resolution with a consumer grade scanner. So really, it's just an aspect of taking more time, right? From that sensor level, and then with your optics, Art, you can speak a little bit more towards this, with your photography background rather, but you're going to have less depth of field, and then you're going to have more issues with your apertures, right?
Right. Yeah. So, when you pick up different cameras and you have bigger optics, uh, depth of field is talking about the area that's in focus in front of your lens, right? You have first the
Yep.
focal point and how far out you're focused. That's one thing, but also the depth of field is really the range of what's in focus and what's visible, what's being recorded. I'm using this analogy to 2D photography. I think it makes sense. You've got a larger sensor, larger lens, and a deeper depth of field, the more kind of money you throw at the 3D scanner. And that means that the software has more information to lock onto. It just works easier if you have higher end optics.
Yeah, no, that
Um,
makes sense. And that'll probably lead into the software side too, right?
yeah, yeah. And if you talk about processing on board, you
Yeah,
got
so processing, I mean, there is an advantage to the consumer side, right? Because a lot of times, because it's less resolution, less data, you don't need as powerful of a computer, right? So that's a really big advantage. Is quite often with a professional system, you need to get a relatively high-end computer for those scanners to work properly and efficiently. Whereas on the
yeah.
consumer side, less data, you don't need a super powerful computer.
Mhm. Yeah, and that's we're kind of swapping here a little bit, but what you're talking about is the hardware requirements kind of from your computer as well. The one last point to make, yeah, about the onboard processing is, if you have a higher end computer, there is faster processor, more memory generally on the
Right.
scanner itself, unless it is a camera that is just directly connected to your computer and it's just a vision system and it's um, most of the processing is happening on the computer. So to distinguish between those standalone scanners where you pick up the scanner, everything is on the back of the screen, it's able to even mesh things out on board. You still probably want to transfer it to computer to get higher end models, but those systems have onboard processing and memory, unlike something that's a tethered camera. And that camera with a USB cable is now feeding that image to the computer. The computer's processing everything. And there's benefits to both. Usually, um, you know, it's a cheaper scanner if it's just a camera connected to your computer. But if it's more on board processing, then that's a convenient package, and there's a premium for that.
Yep.
So talk about software. Software is generally still required. Yes, like there are scanners that promise to give you a mesh straight out of the device. Um, it's always going to have less processing power, but we are impressed with some of the technologies where we're seeing the consumer end kind of starting to compete, and they're getting pretty decent results out of onboard processing. But again, we're still in the very early ages, I think, of 3D scanning. There's still this requirement of having to develop that 3D scan data into an accurate 3D model. And so, software wise, as Paul started to talk about, on the consumer end of things, benefits are you don't have to have a very special computer. And on the professional end of things, you're going to be required to get 64 gigs of RAM and NVIDIA graphics and all of that.
Right.
So, more cost involved as well, but it does mean that you have better algorithms and better processing that happens, and you have more pro level tools. So, whereas on the consumer end of things, it's maybe there's a couple steps there, and you can't really tweak the parameters of those algorithms. If you're having a registration errors, you're seeing noise or like frames are not stacking correctly, and there's like a doubling of surfaces, and then maybe your loop is not closing correctly. Well, on the professional end of things in the software, you could go and tweak some settings, and you can say, okay, increase the keyframe ratio or search for more or less distance for features, and then rerun this algorithm. So that's the pro level tools. And then just overall, like, more speed, uh, better like user interface, more automation on the professional side of things. You can do both. You can make it as manual as you want it to be, and you can create like a macro where it's a one-click solution to from scan to a particular workflow in 3D scan that's being output.
Exactly. Yeah. And I think just to kind of add to that, one thing you'll see a lot of times, in my opinion, is on the consumer side, most of the time you can get things done, right? You can achieve a model that you're looking for. It's just going to take more time, right? It may be a little bit more tedious. You may have to jump from the dedicated software for the scanner over to some sort of other free application, right? To try to get everything finalized, but you can achieve those goals. You're just going to be hopping around and doing a lot more work. So the other kind of big thing that can matter to a lot of people, some people this doesn't matter at all. A lot of people it does matter, which is going to be your accuracy and your resolution, specifically the accuracy. So generally speaking, if you're looking at specs on a consumer scanner versus a professional scanner, the resolution is going to be as stated. So the difference between accuracy and resolution, think of resolution as like the number of data points, and the accuracy is how accurate that data point is to the surface it's capturing. For your professional grade 3D scanners, whatever accuracy is stated, quite often there's going to be certifications, that are actually backing that up. So it's not just a number on paper, but it is certified and documented and tested that it can meet those specifications. For your consumer scanners, generally it's just going to be a number. So if it's just that number, it's hard to trust when it really matters to you for accuracy. And when we get into the practical applications, we'll talk about this a little bit more. But that's a very important distinction between a number that's on a spec sheet versus a number that's actually certified and tested. So with that, did you want to say anything towards accuracy
Yeah.
or?
Yeah, so I want to talk a little bit about, and in a second I'll show an image. Mm, there are like multipliers that people can add to their scan data. So you'll see consumer grade and professional level scanners having listing the same accuracy and the same resolution, and you'll be like, well, how is it possible that this couple $100 scanner is competing with a 40, $50,000 solution? They seem to have the same stated accuracy and resolution. Um, well, again, like Paul is saying, like numbers are just one thing, and when you really look at the data, it's another. But you can also have a model with actually the same amount of like points and resolution in it, but it's going to look very differently. That the data that is noisy um, is converted into a model that may have that many polygons, but those polygons are not going to be representing the real object in the same way. So let's pull up this
Sure, sure.
model here. So you have two scans with two different scanners at the same resolution. One of these scanners is meant for smaller objects and higher detail, and the other one is meant for larger objects. But they both have stated also the same resolution numbers. And so you can see kind of front to back these parts, how one is much more lumpy. It is going to be the same scale. And if you average out some of the surfaces, it's probably close in accuracy. But look at the kind of the close up there. You can't really at all pull the profile um, of that chamfered edge on the inside of the cylinder, but you can on the other model, and both are the same resolution. So just because there's just as many points in both of those scans, it doesn't mean that those are really comparable. And so the more that you're paying for, the more you have this proven accuracy and resolution. Now, again, everybody's got marketing numbers, so it's really hard to say that it's like really straightforward if you just read the numbers. And so that's where you have to test things for yourself or work through with people who have done the testing.
Thanks for sharing that on talking about the factors we should consider when we're choosing a 3D scanner from hardware, software, accuracy, and resolution. So now that we know about these factors, how do you apply it back to a specific use case?
Right. No, that's a really good question. So, as we've kind of mentioned, we went through the more objective, right? So, not to say that it's 100% all the time, but generally speaking, you're going to see these factors versus consumer grade scanners and the other factors on professional scanners. So, the big considerations are, does accuracy really matter? That's an easy one because if you really need the accuracy, then generally speaking, you're going to need to go to a professional scanner for that accuracy. Two, how important is the scan quality, right? And that can be a little bit of a uh, detailed subject that maybe you and me are can get into if we've got some time. Uh, because the scan quality, if you're doing like a reverse engineering type application, a lot of times if you can deal with the accuracies that we're working with, the scan quality doesn't matter that much, right? Now, from like a CGI graphics type application, Sometimes the scan quality can matter a lot. Sometimes it doesn't matter at all. But you need to kind of consider what's acceptable versus what's not acceptable. And I'd say the other big one is going to be time, right? Because when it comes to your consumer scanners, generally it's going to take a lot longer to generate similar 3D scan data than you would get from a professional scan data or a professional 3D scanner, rather. So if you've got the time and you don't need like super detailed scan quality, a lot of time consumer scanners can be really, really good. So, uh, yeah.
Yeah, just to kind of reiterate what Paul is saying, capturing real world 3D objects for different applications may look like sampling a couple of different points. We were moving to 3D scanning from like arms and probing and making measurements off of like um, these devices that just like basically probe in a couple of different areas and allow you to capture the all the different data points that you would need to reverse engineer or measure apart. So think now 3D scanning is just like millions of points of that.
Right.
And scanning something completely is really hard. Our brains see an object and they complete the picture. You don't think about the fact that you can't see the back of my ears or the little cracks or something between my glasses. But to get an accurate 3D scan, these glasses are really quite complicated to scan. And so,
Right.
depending on your app needs, you may need 100% coverage. And that's what we talk about is kind of scan quality. Like, how good does a model look versus accuracy, which is these points. And for people who are concerned with accuracy, often they don't need a complete scan. They just need enough data to make measurements or to reverse engineer, or to fabricate something. If they're fitting a new part to an old scan of an old thing, um, they don't need, necessarily the most complete model. And then again, the last point he's making is like, okay, well, who are you? What do you need? Are you a business that just needs things just to like time is money? And so you're gonna spend more time on your 3D scanning solution because it really is going to save you a whole lot of time in your business and make you a lot more money because we have certain solutions where a tech is on site scanning something. It only takes them a few minutes to scan something, and that is beamed back with a cloud service to an engineer. And the same day, they are shipping out a part, like a gasket for something that they scanned. It's a very quick little outline, and it's the turnaround is very quick. And that solution is going to cost closer to $50,000. Or are you a hobbyist, a fabricator that in a garage has got a 3D printer and you have the time to spend and you can start with a $200 uh, little 3D scanner, a structured light scanner with your own computer. You don't have to get a special computer and you're able to get a pretty decent scan. Now, for $200, you're probably not going to get the best quality, but maybe a couple more $100, then you're getting a little bit more complete watertight model and you're able to like start 3D printing things and doing some modeling in your own. So again, like who are you? What is it that you need? And for I can also speak to kind of my expertise, which I think maybe is the next slide here.
Yeah. Well,
Um,
and before we get into that,
mhm.
just to kind of add to what you're saying, a lot of times you may just need to be doing some sort of mock-ups, right? Where you're just trying to visualize things in 3D space. And in those instances, the barrier to entry of getting a pro level 3D scanner can be really high. Whereas, just starting with a basic low cost 3D scanner just to start doing some of that visualization, that can be a really powerful tool, right? That you don't really need the accuracy for. You just need to be able to kind of get a scan of, say, an interior or something, or whatever the example is, just to start being able to figure out where you need to put stuff.
So all these four objects, they look really, really good and they have really good color information. That's actually a photogrammetry algorithm
Right.
that we work with and off of my cell phone. And they look really quite sharp. Now, photogrammetry, it looks better and more detailed the smaller the object is because the kind of the closer you are with the camera, at least right now. And so some of those models are very, very detailed and really impressive that there was really no 3D scanner except, well, my phone being that 3D scanner involved. Um, and the cost of the software is the main thing there. And so for education and things like that, like it's something that we recommend to our clients.
Yep. Yeah, no, exactly. And just to kind of get into like the main spot where you're just never going to be able to use a consumer 3D scanner is, your metrology quality assurance type applications, right? If you are trying to check tolerances on parts, right, where you need to meet them within a certain spec, it goes back to that certification thing, right? There's just no certification on those consumer scanners, so there's no good way to really track that accuracy. Maybe there's certain really low tolerance applications where you have some sort of a traceable artifact that you use in conjunction with the scanner, but outside of that, 0.1% of 1% type of applications for metrology, which is your quality insurance applications, it's really just going to be a no-go for consumer 3D scanners. But for all other applications, there are certain avenues where they really can be useful, right? So, with that, let's kind of look at just a few examples of some visualizations and kind of what we can do here. So, Art, you did this scan a while back, right?
Yeah, so you have a consumer kind of grade and a professional grade 3D scanner of a motorcycle. And it's flip also to the next slide here. You can get more detail. So your model on the left generally resembles that motorcycle. You could probably get the scale and a few measurements pulled off of that. But when it comes to actually seeing the bolts and the positions and all of that, like the other solution is about $40,000 or 45. Um,
Right.
and yeah, it makes a big difference. So I want to keep an eye on the time here. So Paul, if you want to
Yeah,
switch
no, I think
slides.
just really quickly to add to that, though, is like you can see where there's a lot of applications that that consumer side is perfectly acceptable, right? If you're just doing some sort of a mock-up or you're trying to maybe build a new panel or something like that, right? But yeah, like you said, for the sake of time, we'll kind of move on here a little bit. Again, kind of going back into just a few topics, reverse engineering. Reverse engineering is a really good application where, you know, body panels, looking for fitment of parts as far as like clearances, right? If you're trying to add things like I go to the racing side of things, right? So if we're modifying body panels or we're looking at like where we want to change things on chassis or say fit a new gas tank oil reservoir, something like that for modifying inside of a car. Consumer scanners can be great for that, right? But if you're doing something more professional, like creating aftermarket production parts, that's generally where we're going to want to lean more towards that professional scanner for quality assurance, right? Uh, then for the scientific research, that's generally going to be more towards the professional side, right? And really that comes down to if you're logging a lot of data, the big question I would like to ask is, what's the cost of making a mistake, right? Because if you want to speak a little bit to that, Art, yeah.
Sure, yeah. So we have our clients that will museums and universities that will buy an expensive scanner, but also occasionally will buy a consumer grade scanner. That consumer uh, and scanner, that one is going to be used in education. It's going to be used to maybe get some images on site. But when it comes to really sharing that data between researchers, they're using these high-end systems that have a very, very high accuracy and quality because we're scanning ancient fossils, we're scanning bones, and that data, or like recently a client scanning the edges of tools, stone tools, and they're looking at how the actual wear and tear from a particular region looks like on the stone tools and the chips on the actual tools, like that kind of thing. You really need the best accuracy and resolution. So there's some really cool things we work with, and generally those cheaper scanners are going to be used. Um, they're not going to be used in the final product for high end, yeah, manufacturing or research. I'm trying to think of some other applications that we want to cover here. Like, so if you're a hobbyist and you want to get started on something that is like reverse engineering and fabrication, you could get started with like a cheaper scanner, but you're probably going to need to verify with a digital set of calipers, right? And if you can afford to, then you can move up to the next level of things. So again, we just want to really paint the picture that you are able to do things across the spectrum, but
Right. Yeah. Well, and even just to kind of go to this point here, right? So, you know, I don't want to discourage anybody from buying a consumer grade 3D scanner. So, like for me in art, we primarily deal in the professional world and primarily sell professional 3D scanners. However, there are a lot of reasons for people just to get started out with a consumer grade scanner. Really, that barrier to entry, right? Because this is a technology that is becoming more and more familiar to people, but there's still aspects of it that you may not realize how beneficial it could be for your application. So, if you feel like you want to take the jump, it's really easy to jump in with a consumer grade 3D scanner. It's just to really start kind of learning the technology as well as figuring out what that technology can do for you. The big thing that I would uh, recommends highly, however, is just expectation management, right? A lot of it does come down to you get what you pay for, right? So you can't necessarily, at least in the current market, what we've seen in the past years, still today, and probably within the next few years into the future, a consumer grade 3D scanner is not going to match the capabilities of a professional grade 3D scanner. That, however, does not mean that they're not useful, right? Like they can be, there's been applications where I've picked up, consumer 3D scanners and been able to do a lot of really interesting things with them.
Yeah, well, to paint a little better picture. So, like one thing that comes to mind is probably what you're thinking about is like fabrication of like leather work and like clothing. So, making patterns is one thing that we deal with. So, people want to scan something and like let's say a boat or a car, whether it's decking, right? They want to make a two-dimensional cutout of decking material so they can start their own business and like work with clients who just want to like resurface their boats or it's not, or it's paint protection film. So there's all kinds of vehicles, dirt bikes, motorcycles, whatever it is. They want to scan body panels and then they want to be able to just send it off to a shop somewhere they'll cut out the pattern. And that is a great business model because the actual cutting of a two-dimensional sheet, that's easy. There's like CNC machines that'll do that. But now you've got to give them a good enough file, a model that's accurate. And so we're not seeing a lot of people using cheap scanners in paint protection film and like the boat decking things, but we're recently, somebody that we know is using it for fabric and leather work, and the tolerances out of one of these consumer grade 3D scanners is fine. It's good enough. There's a little bit more to do there with like software, but it's an affordable scanner for a small business doing some leather work for a
Yep.
smaller investment. Yeah.
Yeah. No, exactly. Exactly. So I guess just to kind of wrap up the this whole webinar as far as points to consider. These are just a few different things for you to kind of think about, right? One, as you mentioned initially, Art, user skill greatly affects data quality, right? If you can take the time to work with a uh, consumer grade 3D scanner, you can get some really good results, right? And there's certain instances where somebody just picks up a professional scanner and can't get anything good at all, right? There is a user skill aspect to this. But past that, how much does accuracy matter to you? How much does reliability matter to you? How often are you using it? That kind of goes in with the reliability. Um, and additionally, don't be afraid of the consumer 3D scanner market, right? Just manage that expectation based on their price point. And as we've kind of mentioned throughout all of this, the use cases are really what determine whether you can go with consumer grade versus that professional.
Yeah.
So before we jump into Q&A, you got anything you want to wrap up with, Art?
Yeah, I think that what we're going to talk about is that we do training and we help people get those skills. We help people find solutions. So we're very involved in this. And without knowing your particular application right now in this webinar, our general advice is that there are many tools for many jobs, and you won't hurt you to pick up a consumer grade 3D scanner.
Yep.
Couple $100 tool out there. That's something to get you started, even if you're going to get a higher end solution. I think it's really great to have both because one, it's a lower risk. If you damage it, break it, this and that, um, at least you can get started and figure out how much more you need in all of those points that Paul was making.
Yep. Perfect. Yeah. So just one final thing before we jump into the Q&A. So if you have any questions, we do have a test on our website, which is the which 3D scanner is right for you test. So you can at any point in time go to this link or scan that QR code, which will take you to a form that you fill out. And basically, you fill out the form. One of the Go Measure 3D team will take a look at it and give you a recommendation for what we think would be the best type of 3D scanner for your application. Um, yeah. So with that, uh, anything else on your end, Art, or can we jump into the Q&A?
No, I think you made the point is that like it's hard for us to make a recommendation right now. We're gonna talk about things in the Q&A, but what we're here to do is help you find the right solution, and you can find us through this website.
Yep. Perfect. Awesome. So we'll jump into the Q&A here real quick. So really good question. So looking for scanner for measuring tight tolerances, but you want to introduce yourself into the technology without investing too much. Would I recommend starting with a consumer grade 3D scanner, or would I suggest entering in with an industrial grade scanner? That's a really good question. So the real thing you have to look at in this particular application. So if you have tight tolerances, but your team is hesitant on making the leap into investing into an industrial grade scanner, and this for this type of application, it could be some sort of a from 60K all the way up to 120K industrial grade 3D scanner. So you can get started with a prosumer scanner as a proof of concept, and the big problem is your accuracies. Do your accuracies match? So, in my personal recommendations, if you're looking at a prosumer grade 3D scanner and you see the scanner's accuracy specs, generally the actual accuracy of that device is going to be somewhere between 2x and 4x what it says. So, for instance, in your application, if you need to hold tolerances of, let's call it 100 thousandths, then you're not ever really going to achieve that with a scanner, consumer grade or prosumer grade scanner, even if it says it can do 20, 50, uh, like 0.50 versus point 0.1, 0.050 versus 0.10, if that makes sense. So you need to be very mindful of that. But if you can find something, let's say, for example, you're trying to hold 200 thousandths or zero point 0.2 millimeters. Let's stick with millimeters for now. So if you can hold zero point 0.2 millimeters and you see a scanner that is saying it'll do point zero 0.05, then you may be able to do some decent testing with that. I still wouldn't trust it 100% if those tolerances really matter. But from an introduction to the technology, really just like testing and evaluating software, and even that's another big aspect that I've seen is if you can invest in, say, $1,000 or less 3D scanner just to get some scans done and play around with some software, that can be a good suggestion. However, in most professional settings, I would probably recommend trying to get a relatively low cost service project done, right? With those tolerances in mind. And that's the thing that you really need to keep in mind is if tolerances really matter and that's a critical decision or critical portion of the decision of whether you're going to commit to that stock type of technology or not, a lot of times you can just get a service project done to see if it fits within your specs. So
Um,
hopefully that
just to
helps.
Yeah, to summarize a little bit of Paul, I know his gears are turning. He's thinking about all the different applications. I would say
Right.
the software is one aspect of that workflow. So you can get yourself a 3D scanner that is going to be closely resembling maybe the more expensive version of it. So maybe a tracking a system that uses tracking markers. So like a laser-based system, but the cheapest one available. And then once you get that, you could scan your parts and now the question is how accurately have we captured those models? And that's where you might move up to a more expensive scanner later, where you can start working with that data and already get the software that you'll be using to inspect or reverse engineer. And often actually you can get trials of that software. So we can connect you with some of the best reverse engineering software out there and get you a good trial of it. And you can take your scan data and start working with it. And then once you start
Yep.
sketching and looking at things and realize I need more resolution, I need more accuracy, all you do is just swap out the scanner with another camera. Think of it as just another camera you're going to get. And the one you're going to get is going to be more expensive, but you've already kind of started to prove out the workflow. And I think
Yep.
that's what Paul is getting at. Yeah.
Yeah, exactly. Well, and another addition to that came in for the ISO 9000 certification. So, with ISO 9000, you're going to have to match a scanner that's going to be traceable, right, to some degree. Now, you can have your own traceable artifacts, but for peace of mind, you need to know in your practical use cases, like if you're actually going to be using a scanner in that example for doing those projects, you need a professional scanner that's going to be doing traceability. So that's where, for this particular application, I would recommend you more to go towards a service project with an actual certified device. That way, it's going to do exactly what you want it to do, without spending a lot of time not being able to know how accurate that particular device was or wasn't. So hopefully that helps there. Then let's see, Pauline, are there any other questions in the chat that we have? Anything that I'm missing?
No, there's nothing you're missing. But I like the fact that you guys brought up a good point where there's a correlation between price and accuracy, right? Is that correct from our discussion?
Real accuracy, yeah, yeah, and that's you have to look at it from the perspective of a few things. Generally speaking, on a consumer scanner, they're going to be inherently less accurate, and the reason why is there's a lot of costs associated to maintaining those certifications, as well as all of the components that are used in a 3D scanner, right? Whether it's the lenses, the sensors, there's a full line of things that have fairly high costs to maintain devices that can hold specific accuracies. Whereas if you're just trying to get something that scans something and get it close enough, right? That's where that consumer market really, really works.
Okay.
Yep. Yeah. So if anybody has any other questions, feel free to put them in the chat, or in the Q&A here. We'll hold on for another minute or two to see if there's anything else.
Yeah, we got a question. Taking pictures versus laser line. What do you prefer?
Ooh. So I'm gonna do that in two different parts. I'm gonna treat that as taking pictures as structured light versus laser, and then I'll let you go into the photogrammetry side of things, Art.
Yeah.
So between structured light and laser, I don't have a preference personally. Well, I think personally I would lean more towards structured light as a general process. However, it's very user or use case dependent. So, for example, laser scanners have a tendency on the professional side and even on the consumer side to be a little bit less finicky when it comes to material types. So, your modern lasers can deal with a lot more of your dark surfaces, um, highly reflective surfaces. Like your blue lasers are really good for that. But also, there's really good structured light systems out there on the market that can capture a lot of those details. However, the reason I lean more towards structured light is specifically on fixed structured light 3D scanners. They're inherently just very accurate devices. Personally, I come from a more mechanical quality side of things. So generally in those areas, I'm going to be looking at if it's handheld, then it's going to be from an accuracy standpoint, laser, right? From a flexibility standpoint, it'll be the on the handheld side, structured light because those systems generally don't require tracking markers, so they're really flexible. You can just pick it up, scan, and go. So I'm giving you not a very good answer because it's very user dependent, but to give the three categories, if you need a scanner that you just need to be able to pick up, scan an object right away, be done. Handheld structured light, in my opinion, is the best. If you need to be able to have a handheld scanner that is really accurate, handheld laser is going to be the way to go. And then if you just need the most accurate scan data possible, fixed structured light is still the best. Or
I'll
if you
give my
want
answer. I'll try to keep it short. Yeah, it's
or yeah.
I would say structured light as well. Maybe these are the reasons Paul is mentioning it. We have some great structured light systems that we love, and something about structured light scanners is that it's taking snapshots. So it's taking a whole area at once and it's overlaying that, and there's not as many gaps. Whereas with a laser, I would choose a laser if I had to have the most accuracy for the maybe like a consumer grade level. Then maybe I'd go laser if I needed the accuracy. But I don't like laser scanning as much because those laser lines, as you're moving your scanner across, if you're moving a little bit too fast, they start to create like a little gaps between them. And so you have to actually move your scanner like this when you're scanning with a laser. And that creates more coverage. There's more skill involved in using a laser to get a nice complete scan. And again, complete scan and accurate scan, there's an overlap, but they're separate things. So it depends. I'd say if generally you're asking us, what do we prefer? We all prefer structured light because it's just easy, looks nice. But then if we complicate the picture, we would answer the question differently. To talk a little bit
Yeah.
about pictures in terms of photogrammetry, photogrammetry is a whole different world. You can use scale bars to ensure scale and somewhat accuracy, but it really doesn't really compete like photogrammetry in the same way that lasers and structured light do when it comes to accuracy, fidelity. Yeah.
Yeah, and I would kind of give the toolbox analogy, right? Like asking what technology I like is like, do I like a screwdriver more than a wrench in some ways, right? Which one, it just depends on the application. So hopefully that helps. Well, thank you all very much for your time. I don't think there's any more questions, are there, Pauline?
No, I think we're good. I just
Yes, so
think we
just
should show the last slide where if anybody has any questions, for us, they can always contact us at info@gomeasure3d.com or visit our website at gomeasure3d.com.
thank you very much.
Well,
And
we
is
might.
there a questionnaire at the end of this one, Pauline?
Yes, there is. So after we close this webinar, there is a survey you can take that will help us improve on our future webinars and yeah, just getting feedback so we can present topics that you would be interested in watching.
Mhm.
I just saw another question. It says, can you see it, Paul? It said, what is the best 3D scanner to get 3D CAD files directly without using markers on the original parts? Having to interface the parts through other software is very time consuming. Accuracy, our case is plus minus point
Yep,
zero
I got
six
it.
two five inches. Yeah, thank you.
Yes, so that's scanner doesn't matter too much on that application. It's more going to be the software that you're using. So for that specific question, actually, I think the best recommendation I can give you is to go to our previous webinar we just did on reverse engineering, specifically with Quick Surface. So Costa from Quick Surface helps us kind of break down really practically what it takes to get scan data and have that being turned into CAD because there's no real easy button. And that's a very deep topic. So I would highly recommend taking a look at that webinar. And also, if you want to talk more about it, feel free to get in touch with
Yeah,
us.
this is the one thing that we're here to educate people on. There is no 3D scanner that will create a CAD model for you. There are points and polygons that are exported out of the 3D scanners, but nothing is creating a perfect CAD model that understands like datums and engineering intent and tolerances and things like that. This is like
Yep.
Paul is saying, is all still requires a human.
Yep. Yep. We definitely check that webinar out. So awesome. Well, thank you all very much for joining our webinar. And yeah, if you have suggestions, feel free to enter those in the form here at the end. And we look forward to seeing you all in the next one.